Okay, we're going to work with some actual trig functions today. Get excited. But first, we're going to do some radicals as a warm-up. So if you're working with square root 2 minus 3 square root 2, and if the whole thing is squared, we're going to have to multiply it out. So write it out twice, and then I'll need to take like square root 2 times square root 2, square root 2 times 3 square root 2, again, and then square root 3 times itself. So if you multiply everything together, you're going to end up with that. And then we can simplify some radicals and combine some like terms. Square root of 4 is just 2. Put your middle terms together, it's negative 6 square root 4. If you break down square root 4, it's just 2. So you end up with negative 12 in the middle. And then that last one, you get 6. Put everything together, and you end up with just 4 for your final answer. Okay, on to the trig functions. So the definitions of the trig functions that you might be used to from geometry may have involved right triangles. We're going to get to those in chapter 2. We're going to start with some different definitions based on the coordinates of a point on the terminal side of an angle. So I just drew a little angle down here in standard position, and its terminal side goes through the point negative 3, 4. So these coordinate definitions of the trig functions are nice because they work in all situations, whether it's an obvious triangle or not. So if I want, for example, sine of angle theta, and my angle is the one I drew up there, these are kind of just something you have to memorize. So sine is your y coordinate, which in my picture is 4, divided by r. Now r is the distance between 0, 0 and my point. So basically, it's just something you can find the distance of using distance formula or Pythagorean theorem. I just use Pythagorean theorem usually, so I would do x squared plus y squared equals r squared, have negative 3 squared plus 4 squared. Oh, by the way, they use r instead of c to represent that because it's not obviously like a right triangle. So they use r as like the radius of a circle if I was to draw a circle for my angle rotation. So on this one, I would end up with 9 plus 16, 25 for r squared, and then take the square root and you get r equals 5. So my sine value for that angle would be my y coordinate divided by r, which is just 4 over 5. Cosine is your x coordinate divided by r. Tangent is your y coordinate divided by x. And then if you want the other 3 trig function values, it's easier just to like remember the reciprocals and which ones pair together. So to get my cosecant value, it's just the reciprocal of sine. So I can just flip my sine value and have 5 over 4. And then like cosine and secant are reciprocals. So you can just flip cosine to get secant. And same with tangent and cotangent. You might notice all these like, hey, my denominator of all these fractions can't be 0 because I can't divide by 0. If it is, your trig function value is just undefined. So let's do one. So if you have an angle in standard position, and its point on the terminal side that we're given is 8, negative 6. I plot that here. So drawing in my angle. Doesn't really matter which direction I make the rotation go. We're just going to draw it this way. Okay. So finding my values of sine, cosine, and tangent. If you don't have r, you probably want to find it first. So let's do that. X squared plus y squared equals r squared. So I've got x is 8, so 8 squared is 64. Y is negative 6. Square that, you get 36. So r squared is 100. And take the square root. You end up with r equals 10. Okay, now that you have your values, you can just plug them into your definitions. So sine is y over r, which is just negative 6 over 10. You should simplify your fraction. Cosine is x over r. So we've got 8 over 10, or 4/5. And tangent is y over x. So negative 6 over 8, or negative 3 over 4. So down below, it asks us, what if we chose the point 4, negative 3 instead? So if I come over here and I look, 4, negative 3, if I had drawn this better, is actually a point that is on the same terminal side. So all your trig function values are actually going to be the same thing because it's on the same like ray that makes up the terminal side of your angle. So they'll have the same values. So no matter what point I was to pick on this terminal side of my angle, I'm going to come up with the same trig function values because they're proportional. They all have the same angle measure when I draw that angle.